what is the topic of the day? It's finding the equations of straight lines when given 2 points. And at the end of the last lesson, I did some examples for you. And I want to start today by just doing one more before we practice it, before you practice it yourself. So let's just quickly have an example. And this first example says, find the equation of PQ given the points P and Q. And in the last lesson, I was showing you 2 methods for doing this. There was method 1, there was method 2. And before I do my examples, both methods are correct. You could use whichever one you like, but you just need to have, you need to be comfortable doing them. Now, in both these methods, the first step is the same. So if I want to find the equation of a straight line, who wants to tell me, based on the last lesson, what my first step is always going to be? You can raise your hand and I can unmute you, or you can put it in the chat. What is that important first step? Who is feeling like, just pop your hand up and you can just tell me. It's easier than, Naomi. Naomi says the right thing. Vumil also says the right thing. Find the gradient. Yes. So in both these methods, you need to find the gradient. So just to remind ourselves, the gradient formula is just going to be that, change in y over change in x. So why don't you guys find me the gradient between these 2 points? Find me the gradient between these 2 points and pop it in the chat. What do you get as your gradient? Okay, so there's Naomi's got an answer. Who else got an answer? Let me see if I can remember. So go 3 minus 2. And I've got 1 minus 6, which is going to be 3 plus 2 over minus 5, which is 5 over minus 5. I don't have to do all these steps. And we get minus 1. Okay. Fantastic. You guys are winning, winning, winning. So if we are using method 1, what we normally do is we write down, so we learned in the last lesson, the standard form of a straight line is y equals mx plus c. Okay, we learned about that. Now in method 1, if you want to use that method, we normally start by writing in the gradient, which was, you've established minus 1. So we go minus 1x plus c. And so we don't know what c is, but we're going to use one of the points, either p or q, and I'm going to choose the point q, and so I'm going to write that over here. So that would be method 1. In method 2, it's slightly different. We start by going y minus y1 equals m, and then x minus x1. And so because we know what the gradient was, it was minus 1, we can do that. And then over here, we're just going to have an empty space for a point. And that point, I'm going to choose the same point. It's just going to be 1, 3. Now, if we are going to find the c value in method 1, what we need to do is sub in this point 1, 3 on the line. So I take this 3 and I put it where y is. And then when I have an x, I'm going to put a 1. I get c. I want to know from you at home, what is the value of c that I'm going to find? What's the value of c I'm going to find? So I think this part over here is quite important. It's -1, but when you bring it to the other side, it becomes +1. And so you get C is 4. And the equation of my straight line is going to be -1x or -x plus 4. So that would be the equation of the straight line. Now, using the other method, even though it looks slightly different, we should get the same answer. So what we do here is that this little y1 is just the y1 over here, and this little x1 is just the x coordinate from that point that you're subbing in. And so let's see what we get. We hopefully get the same answer. So I go y minus 3. No, that's too big. Go back. Y minus 3 equals -1 x minus 1. And then I get y minus 3 is -x plus 1. And then when I bring the 3 across, I get add 3 on both sides, I get y equals -x plus 4. And so the good news is for you and me that both methods get us to the same answer. I want to ask, who uses mainly method 1? Put M1 in the chat. If you mainly use M2, put M2 in the chat. Just want to get a feel for how many students do it in different, which ways they do it. Both methods are fine. But I just know that teachers, generally, those are the two methods they use. Okay, so it looks about sort of 60%, 70% method 1, 30% method 2. And like I said, they're both perfectly correct. I'm not going to say which one is better. Some students use method 1 in certain situations and method 2 in other ones. Okay, well, what I want you to do now is I'm going to leave that example up on the board so I can answer questions. But for the rest of us, if you don't have a question, I want you to find me the equation of the line passing through the points 3, 6, and -1, -5. So you're going to do that. But for those students who are unsure about anything, I really want to encourage you, ask a question. One of the lovely things about doing it live like this is you can really ask any question, and I'm here to help. But if you feel confident enough to get going, then there's your question. Okay, Kelobogile, how can I suggest that you start by doing what was the very first thing I did in the previous question? I try to find the gradient. And so I want to suggest that you start by finding the gradient in this next question. Does that help a little bit, Kelobogile? Or do you have a more detailed question? Maybe you can come on, just put your hand up and we can help you out. Okay, Nokotula, let's go to you. So I'm going to take away method 2 because most of the questions are about method 1. So let me just explain a bit more about how this worked. At this step, we took this point. So this is an X and this is a Y. And we put the Y into this space. That's why there is a 3 here. And then where there's an X, we put that 1. So we subbed in was the first bit. And then we said we have 3 equals -1 plus C. In order to move this -1 across, we add 1 to both sides. So then we get 3 plus 1 is C. And that's how I got C is 4. Earlier in the question, I'd already worked out that the gradient was -1. And so when we take the standard form of a straight line, it's -1 or mx plus c. Was that a little bit helpful, Nokotula and Kobolangeni? Let me know. Or if you have a more detailed question, what you can do is you just raise your hand and you can talk to me audibly. Let me go through this next example with everyone. So I want to find my gradient. Remember, y is on top. minus 5, minus 6, and then minus 1, minus 3. Notice how the y's are on top, and if I start with this point here, I always start from one side. So I get minus 11 over minus 4. Let's just check that. Minus 5, minus 6, minus 1, minus 3. Yes. So my gradient is 11 over 4. Now you can change it to a mixed number, but my suggestion is leave it like this. And what I said last time was you start by writing out, the standard form of a straight line is y equals mx plus c. That's actually given on your formula sheet. Now you can sub in for that m value because you found it. And so before you guys continue, I want you to think, okay, I'm putting this part here. What did I put here last time? Or what do you think I'm going to put where that hashtag is based on the method I used last time? I'd love to hear a voice from a student who feels brave. You can tell me, what am I going to put here in a moment's time following the method? Pop those hands up. I'll give you a virtual bar 1. It's not as tasty as a real bar 1, but it feels as good. So what I'm looking to know is, what is the next step? I found my gradients. So I put it here, but in order to find what C is, I need to do a next step. Don't worry, Vimal, I will definitely repeat the question now. So I was subbing in X and Y. Yes, exactly. But where do I get that X and Y from? I'm going to choose a point here. So I'm going to choose the point 3, 6. And now I'm going to sub it into that equation of the straight line. So where the Y is, so there's a Y. So I'm going to put a 6. And here's an X. So it equals 11 over 4 times 3 plus C. And now I want to get my C by itself. So I need to say, okay, well, how do I get that by itself? I suppose I need to get 6 equals, I could use my calculator, but I should get 33 over 4. So I just multiplied that 3 and 11 over 4 together. And now I want to move this away. So I'm going to get 6 minus 33 over 4 equals C. Can someone tell me what C is? Naomi, you can choose any of the 2 points that are given. So if you look at the beginning of the question, there were 2 points. You can choose either of those 2. I chose the simpler one. So it looks like people are saying, well, let me use my calculator. We go 6 minus 33 over 4 minus 9 over 4 is what I get. Minus 9 over 4. And so what is the equation of this line in the end? It's going to be y equals 11 over 4x minus 9 over 4. And let's just do a quick recap of the steps. So step 1 was find the gradient. So that was this one here. Find the gradient. Step 2, sub it in so that you have the standard form. Step 3, choose a point. I could have chosen either of these 2 points. Then step 4 is find what C is. And then I suppose you could say step 5 is write out the full equation. I see Alata has a question. Can we unmute Alata while I put the next question on the board for those who would like to have a go? There's a question for you. It says, a line has a gradient of 4 and passes through the point 1, 6. Can you choose the correct answer? Is it A, B, C, or D? And I want to give you some time to try that. Alata, what's your question? Or maybe you are...
The audio is not connected, Mr. Ace.
Okay, no problem. So everyone, it's time for multiple choice question land. And you are given that. I want you to try and work out what you think is the correct answer. Okay. And if you have a question, you can just raise your hand and you can ask me a question audibly. I promise it does work really well. Otherwise, put your question in the chat and me and Lebo will try our best to help you. Okay, I can zoom in a little bit. Yes. How about that?
Mr. S, Ndumiso asked if you can please repeat the steps again.
Okay, so step one was find the gradient. But the good news is this question, the gradient is given. So step one, we actually get for free in this question. Step two was to write out the standard form of a straight line with the gradient subbed in. And in this case, we've only been given one. So that's the only point we can use. So we're going to use the point 1,6. So we choose a point we're going to use, which is step 3. Then step 4 was to sub 1,6 in. And then step 5 was find the right answer. So I'll let you do those last 2 steps and let people vote. And then I will come along and answer. So it feels like I go 6. And then I need to get C by itself. That just means moving that across. So C should be 2. So what's my final answer? 4x plus 2. And is there a 4x plus 2? There is. And I declare that answer A is correct. Yeah. So I can definitely see students are getting it. And so I am obviously only doing method 1, but if you did method 2, you should have also got that correct. Let's have a little vote. Thumbs up if you're feeling comfortable so far today. Thumbs down if you're feeling a bit overwhelmed or a bit lost. Let's have a quick little vote. Okay, now, I know that was a bit quick, so can I suggest that I put this up on the board and those students feel comfortable, go ahead and do it. But for those students who are unsure, let me talk you through the 5-step process. So I'm going to make you a little note on the side. So this question says, what is the equation of the straight line that passes through these 2 points? Now, in these types of questions, I'm not giving you the Cartesian plane, but sometimes they will give you a Cartesian plane. So you can imagine like minus 2, 5 might be like a point here, and 3 minus 5 might be a point down here. What we're trying to do is figure out the equation of the straight line that goes through those 2 points. Now, we have 4 choices, but always we need to find the gradient first. And so when we're finding the gradient, I want you to use this formula. So let's have everybody find the gradient and then put the gradient in the chat. So if you're completely new, all I want you to do is take these 2 points and try and find the gradient and then pop it in the chat. Then and I'll put the steps on the board so you can use them for this one. See if you can follow my 5-step plan. So everyone is saying -2 for gradient. I don't know what the answer is yet, but let me see if I can do it. So -10/5, I get -2. Yeah, and that makes me happy because when I look at my picture, you can see the gradient is negative. So sub into this, well, what's that going to look like? Now that I know what the gradient is, I've got to sub it into this. And so I get y equals -2x plus c. Can you do steps 3, 4, and 5 and then try and choose the correct answer there? We'll find out now, Melon. I'm not sure exactly what the answer is yet, but we're going to find out in the process. Now, what point should I choose? Should I choose -2,5 or should I choose 3 - 5? I think I'm going to choose 3 - 5, but you didn't have to choose that. You could have chosen either. So I do that, and now I need to sub in the point. Now, what does it mean to sub in? Well, where there's a y, I have a -5, and where there's an x, I'm going to have a 3. And now I've got to find what c is. So I've got -5 equals -6 plus c. And then I think I have to take away 6 from both sides, which means I get -11 is, oh, have I made a mistake? Let's have a look. -2 times 3. Oh, I have made a mistake. Look at that. Even math teachers make mistakes. -6 plus c. So if I add 6 to both sides, what happens? Well, this becomes a +6 on the side. And so my c should be 1. Is there a graph that matches what I found? So I seem to have found -2x plus 1. So the students are overwhelmingly saying A, and if I look at A, it has a -2 gradient and a +1. And just going back to the previous lesson, this +1 is actually the y-intercept. So that would be, we did this a little bit, but that would be the y-intercept over there. It would be 1. And the gradient would be -2. It's completely fine, Kakiso, to use -2,5. You should get the same answer. Okay, so you should get the same answer as me. It shouldn't be a problem to use a different point. You just need to make sure that your algebra is okay. Should we squeeze in one more? I'm going to come back now. I just want to find another example. Sorry if I'm making you dizzy. I want you, let's just do one more before the break. And I'm going to leave the working up on the screen. I want you to find me the equation of this line. We'll call it LM. So let's do that. And then after we've done that, we have a break. So can you find me the equation of the line going through the green 2 points? Let's do it. And you're going to fly solo now. This is your solo flight. If you have a question, you're welcome to ask. But otherwise, unless there's questions, I'm not going to intervene. ask yourself what that first step was. What was the first step we found? I like it, Tsugatsu and Kokotsu, looking good. Now, what is my, if we think about the next step, so we've done step 1, 2, and 3. What about steps 4 and 5? What are we going to get for that? Okay. So I'm not going to put the step numbers in, but I know I need to sub in. So 10 is 5/2 times 2 plus c. And then if we multiply 5/2 times 2, I think we get 10 equals 5 plus c. And that means if we take away 5 from both sides, we should get c equals 5. And then we found the gradient. It was 5/2x. And we know that c was 5. And so did you get 5/2x plus 5? It looks like Nati and Keklejo did. And it looks like we are all doing fantastically well. And even if you're not, don't worry, because there's more practice to come in the second half of the lesson. But guys, from my point of view, I can see that you are making straight lines like you are in charge. You are showing them who's boss. So I think what we need is a break. So when you've been working hard for half an hour, I call it the save as process. You know, when you have to save, or maybe not anymore, you don't have to press save as, but back in the day, you had to click save as so that your brain could absorb the knowledge. And so what I want to do now is I want to ask everyone to stand up. I'm going to do the same, and we're going to allow our bodies to just unwind for a bit so that we can carry on learning after this. Okay, so, and turn your cameras on. And Orati, when I see that hand, I will come to you later. But I know right now the biggest priority is to just let our bodies unwind. So stand up, take a nice deep breath.
Please turn on your cameras, guys. Let's see your lovely faces.
So I didn't do biology at school, but I hear oxygen is important. So let's take another deep breath. And swing those arms. Let all that tension melt away. Okay. And what we're going to do is we're just going to start with a little shoulder stretch. Just stretch those shoulders out and to get a bit tense when we're concentrating hard. Okay, and switch to the other side. There we go. And then just roll the shoulders back. 1, 2, 3, 4, 5. And then roll them forward. 2, 4, 5. Okay. So hopefully that's got you a bit more relaxed. Maybe we can do some high heart rate stuff. Let's do virtual skipping. So what we're going to do is pretend you have a skipping rope in your hand and make sure that you've got some space so that you don't whack anyone or spill your tea or coffee or something. And we're just going to do 30 virtual skips. So we'll start in 3, 2, 1. 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15, 16, 17, 18. 27, 28, 29, 30. Okay, that's it. And then just take a seat, and you should feel that your body is like, oh, I haven't been doing maths, and your body is busy circulating blood all around, and the oxygen is just flowing, and just enjoy that for a second before we start something else. Okay, so what I want to do now is a little puzzle question, and it's called Maths 24. And for those students who are new, and there are quite a few new students, all we try and do is make 24 using these 4 numbers. And so you have to use them all, and you can't use them more than once. And so let's just see if anybody can get the, I can feel my heart rate is still high. So see if you can get Maths 24 while I catch my breath. I will explain, but I'm tired.
Ja, I'm also low blank fit.
Yeah.
I started jogging the other day and I put in 10 minutes. And
You
then
started
when I
jogging?
got to, I was like, I'm going to do it for 10 minutes. At 3 minutes, I was already dying.
Yeah, it's all about, it's just about what your body gets used to. Hey, it's crazy. Like we adapt, you know. But I know that feeling when you haven't run for a long time, and it's like, what?
Yes.
The body protests a lot. Okay, let's have a look here. Lolita there's quite a few students. So let's say 5 times 3 plus 4 plus 5. Yes, that seems to be the way of doing it. That would be 15 plus 4 plus 5, and that is 24. Yes, well done. Okay, you guys have smashed Maths 24. I think sometimes we do 2, but today, because you're working so well, and I do want to talk about parallel lines still, we're going to go back to our learning. So yeah, well done. And I hope that your brain feels like it's had a bit of a break before we go into the second part of the lesson. But very nice participation on the Maths 24. So huge shout out to the students. Thank you. All right. The second part of today's lesson is about this picture over here. And I want to ask you guys to give me some comments about what you notice in this picture. So we do have 2 straight lines. What do you notice about these 2 straight lines? I'd love to hear someone's voice. If anybody feels like popping their hand up, just giving us a little, what are you thinking? When you look at this? Yeah, let's unmute Pabalo. Pabalo has some comments or comment to make. Hey, what do you notice, Pabalo?
Yeah.
Okay, I think there's a little bit of a problem with audio there, but let's go to Kokotso. Kokotso, what do you think? What do you notice when you look at these 2 lines?
I noticed 3 things on those 2 lines.
Okay.
The first thing is that they are positive. The second, they are parallel, and the third, they have the same gradient.
You are on form. So you've hit it out the park. So as we look at these 2 straight lines, Kokotso has nailed it. These gradients are both positive, but not only that, they are parallel to each other. And what parallel means is they're equidistant throughout, or they're the same distance apart. And one of the key things that we need to know for the section is when lines are parallel, they have the same gradient. What is that same gradient in this case? What is that same gradient? What's the gradient they have in common? You can pop it in chat. Well, if we look at the formula, there's a formula here, and we know that the m in y equals mx plus c is the gradient. And so we can see here the gradient is 2. And if we go back to, I think, our second lesson, we can even see this on the graph. if I go across by 1 and up by 2, we can see that on both these graphs, they have this across by 1, up by 2 thing going on. So not only is the gradient 2 in the formulas, we can also see it visually. And so these two lines are parallel. And whenever we know two lines are parallel, we actually know they have the same gradient. And so that's something that we're going to use going forward today in a question. Give me a thumbs up if you understand that basic fact. If you understand that parallel lines have the same gradient, give me a thumbs down if you're unclear about that. So another way maybe of showing you this is if I wanted to draw another line parallel to these ones, I would have to make sure the gradient is 2. And as long as I kept the gradient to be 2, then that line would also be parallel to these ones. Oh, okay. So can you see this one over here? I've made sure that the gradient is 2. And now I know that all 3 of these lines are parallel because they both have this gradient of positive 2. Okay, let's try this out. A line parallel to this line would have what gradient? Choose A, B, C, or D. A line parallel to this would have what gradient? You've got to give me A, B, C, or D. Yeah, because we know that the gradient in this line is 3. And if that line has a gradient of 3, then a line parallel to that would also have a gradient of 3. You'll notice that, yeah, so that's it. So the answer would be A, piece of cake. So how could we ask this in a question to you? Well, what we could do is I could say to you, determine whether or not the following lines are parallel. So determine whether those two are parallel. Now, this is, if I want to determine whether these lines are parallel to each other, I need to know their gradients. And so what I'm going to do is I don't know what the gradient is now because they're written a bit weirdly. What could I do to make it easier to know the gradient of each of these lines? What suggestions? Has anybody got a suggestion they could make? You can pop your hand up or you can put it in the chat. How can I know what the gradient of each of these lines is so that I can then determine whether they're parallel or not? Who has some ideas from class? Ah, yes, Iyazi, Naomi, Mokholele. You make Y the subject of the formula. So you write it in what we call standard form. And actually, now that I look at the second one, I'm just so used to Y being on the left. But if I write it out like this one over here is actually in standard form. It's this one which is difficult. But if I move the 2x to the other side, I get minus 2x plus 1. So now I can see that the gradient of this one is minus 2 and the gradient of this one is minus 2. So we can say the lines are parallel because gradients are equal. And both those gradients were minus 2. Yeah, exactly. So they are parallel. So I want to give you a chance to have a go at a question like this. So here is your question. I'm going to give you these 2 lines, and I want to know, are these 2 lines parallel? And you need to work out for me whether or not they are parallel. Off we go. You can do it. I've left the other example on for you to kind of give you a scaffold or like a guide. Who wants to share their thinking on this? How would you approach this problem? I'm very curious to know from some students what their first step would be. So pop your hand up if you're willing to share with us your first step. What's your thinking on your first step? Let's go to Tigavatso. Let's unmute you. What do you think our first step should be?
Good afternoon, sir.
Hello. What is our first step going to be?
We have to make Y the subject of the formula.
Perfect. So what would you do with this one? What do you have to do?
I have to transpose +1 to the right, then it's going to be -1.
Okay, so that becomes x minus 1.
Yes, sir.
Now, what about this one, this red one?
We have to transpose x to the right, then it would be -x.
So negative x plus 3. Okay, you have done the step where you've got them in standard form. Do you know how to identify the gradient in each of these?
Yes, sir. Oh, wait. Oh. Yeah, I think I do, sir.
Okay, go for it. What do you think? It doesn't matter if wrong or right. I just want to see your thinking.
The first one, the x is positive, then the second one, it's negative.
So if I said to you, for the black one, what would the gradient be? It would be?
+1.
+1. And for the red one, it would be?
-1.
Okay, now here's the big question. Are they parallel lines?
No, sir.
Okay, so they're not parallel because,
Parallel lines have the same gradient.
yeah, gradients not equal. Basically, you know that -1 is not equal to 1. And so these are not parallel lines. Thank you. That was brilliant. That was really good. Okay, now here is the last question of the day. We're going to finish with this one. We're going to climb the mountain and then, sorry, my excitement got the better of me and so did my mouse. So here is the question to end the day. You are given the following question. You need to determine whether or not the following lines are parallel. There is a line passing through those 2 points, and then there is another line where they give you the equation of the formula. I'm pushing you guys, so if you don't know how to do this, don't worry. I am pushing you, yeah. Can you help me find out whether these 2 lines are parallel or not? And I'm going to give you some time to start on this, but I'm going to ask for tips from the class in the chat if you feel like you can give us a tip. Who wants to give us a tip? Yes, Leseko has said for the green one, make Y the subject of the formula. And then Mbadi has said for the blue one, find the gradient of the blue line. Because all you need is the gradient of this one and the gradient of the green one. So find the gradient of the blue one, and for the green one, make Y the subject of the formula, and then you should be on your way. So how would we, oh, I think I would just move the minus y. Yeah. Give it some time and see if you can do it. Can you remember how to find the gradient given 2 points? Okay, so are they parallel? Are they not parallel? We don't know yet, but if we can find the gradients of both of them, we can compare. So let's see, -3 minus 1, -4 minus 2. So -2 over -2, which is 1. Are they going, so the gradient of the blue one, the gradient of the blue line is 1. Now, what is the gradient of the green line? It looks to me like there's a 1 in front, so it should be 1. So what does that mean about these two lines? In this case, we can say the lines are parallel as gradients are equal. And we can just say, sometimes they say M1 and M2. So if we wanted to, we could say M1 and M2. So M1 equals M2 equals 1. And so they are parallel. All right. I have pushed you quite hard today. And especially for our new students, I don't want you to be discouraged if you felt like today's lesson was a bit fast. This was our 3rd lesson. But yeah, well done, everyone. And Lebo, if I could ask you to put the link to the poll so that we can get feedback from the students. And everyone, if I could ask you, please do give us the feedback in the poll so that we can adjust our lessons to be the best they possibly can. And if you have any other feedback, if you have something that you would suggest for future lessons, don't be afraid to put that in the chat as well. And then we can consider that going forward. Okay, but it was really nice being with you today. I hope you enjoyed our lesson. I'd love to hear from our new students what they thought was good, what they thought could be better. I know it's always a bit strange starting, the first lesson, but experience says that it gets easier the more you do it. And so, yeah, keep that feedback coming. So Naomi, I use a mixture of different questions from all over the place. I try and put them together in a way that it logically leads together. And so I'm always looking for different questions that I can use. So Annie, method 2 works the same as questions like for question 1. It just is some teachers teach that. And I know students like to see that it is a legitimate method. And so, but it's fine. Most of us seem to be using method 1.